This is section 3.9, the perpendicular bisector. So you'll need your tools for this section, so make sure you've got your tools. So the first thing we've got there is equidistant. So what equidistant means is at the same distance. So equa kind of sounds like equal, so it's like equal distance. Okay, now the next thing is bisector of a segment. So we've talked about bisectors before. Bisector of an angle basically took an angle and split it down the middle. That's the same thing that a bisector does. So bisector of a segment is either a line, ray, or segment that intersects the segment at its midpoint but does not contain the segment. So it's basically a line kind of cutting through here. Say C is our midpoint, which would be an equal distance away from A as it is away from B, which is what these little tick marks mean there. So C is the midpoint, equal distance away. Basically there's a line, a ray, or a segment that cuts through that midpoint. That would be called a bisector because it's splitting this into two equal halves here. Okay, so that's what they're talking about, bisector, same as bisector of an angle, cutting something in half. Now the next thing here is a specific type of bisector. So here we've got perpendicular bisector. So again, bisector, splitting a segment in half, but this time it's going to be at a perpendicular angle. So it says the line that bisects and is perpendicular to the segment, and then they give an example here. So L is the perpendicular bisector of segment AB. So basically I've got a segment here from A to B. I've got a line that goes through the midpoint, so my line L goes through the midpoint, so right here there'd be a point in the middle, and then it's also at a 90 degrees with that segment. Okay, so one way you can do that is you can use, your ruler, measure out halfway in between. I think that's a 2-inch line there, 1 inch in between, and then use your protractor, measure out at 90 degrees, and so on. That's one way to do it. Now, the way that the book kind of shows us how to do it is actually using just an unmarked straight edge, or just think of it like your ruler. You're just not going to use it as a ruler. You're not going to, measure 3 inches or centimeters or whatever. You're just using it to make a straight line, and then also a compass. So we're actually going to use circles here to make a perpendicular bisector just like we did here. It's kind of an interesting process. Okay, so what you're going to need to do, and this is activity 2 on page 166 if you want to follow along with that, or if you're having a hard time doing this later, you can follow through that activity. So it says given points A and B, so basically you're going to put in point A here and a point B here, and then construct a segment between those. So I just drew an A, a B, I think I put them an inch apart, something like that. Doesn't matter, I wouldn't put them too far apart because you're going to have to use your compass for this. But just something kind of like that with an A and a B, and then a line through those, or a segment connecting those. Then what we're going to want to do is we're going to want to construct a circle A, and then it has AB behind that. That stands for the radius. So what we want to do is we want to make a circle around A where the radius is A to B. So what we do is we put the stab end on one of our points, so like the stab end on A, and the pencil end on our other point. Okay, so stab end on A, pencil end on B, and then we're going to go and we're going to make a circle. So do your best to make a circle around there. Hopefully you guys can see that okay, because I know the pencil doesn't always show up very well. It might move on, you might have to adjust it a little bit. But a circle, something kind of like that. So a circle A where the radius is A to B. Now for the next step, we're going to do the same exact thing, except for now we're going to put our stab end on B and our pencil end on, oops, I moved it there. Stab end on B, pencil end on A. Okay, so it's going to be the same exact thing, just you're flipping your thing around, stab on B, pencil on A this time, and we're going to make a circle. Okay, so now what you should have is 2 interlocking circles. Both of their radiuses should be from A to B or from B to A, so the radiuses should be the same distance, so your circle should be about the same size. Then our next step is to name the intersection of those 2 circles CD. So where they cross here, we're going to name that C. Where they cross here, we're going to name that D. Then what they want us to do is they want us to make a line connecting that C and D. So we're going to go and make a line through the C and the D. Just kind of like that. And then the next thing they tell us is where that crosses, so where my red line I just drew in crosses that original segment right there, I'm going to name that point E. Okay, so basically what we just did here is we used our tools to make a perpendicular bisector. Because if you look at this red line here compared to my black segment I started with, that should be a 90-degree angle. Okay, and I could check that by, using my protractor, lining it up there, whatever, and it should be pretty darn close. I can't really see, but it should be pretty darn close to a 90. Then also, if you actually did use a ruler here, so I don't remember I measured this out to an inch, so when I did this, if it was an inch, my middle line, that red line there, should be at a 1/2 inch, which it is. So I did that there without even using my protractor to get a 90 and without my ruler to, measure halfway in between. Okay, so this is how, if they asked you to make a perpendicular bisector on your assignment or on the test or something, this is the method you're going to have to use by using your unmarked straight edge and a compass, which would be your construction tool. So anytime they say construct, you're using those tools. Okay, so that would be a perpendicular bisector there. From C to D would be the perpendicular bisector of segment AB, and then the midpoint of that segment would be point E. The next thing we're going to do here is, I don't really know how to say this name here. It's the name of some guy. It's like Voronoi or something like that. I don't know. I always just call it a V diagram because I don't actually know what the guy's name is. But it's just a way of figuring out how close points are to certain locations. So what I would do is, in my notebook, I would just draw 3 points, X, Y, and Z, a little bit away from each other, but not so far that they're just, like on the corners of your pages, but a little bit away from each other, kind of like what I've got here. So again, we're going to be using our tools, and basically what our goal is to figure out which points are closest. So like all points that are closest to each one of these points. So if you think about this as X, Y, and Z are all airports, and you're a pilot flying a plane, and all of a sudden you're starting to have engine trouble and your plane is going down quickly. So what you want to know when you radio in is you want to say, okay, these are my coordinates, this is where I'm at. I need to land as soon as possible. Where is the closest airport? So like if I was like over here, I'd probably go to Y, right? Because that seems like it's the closest. If I'm in here somewhere, it might be kind of questionable which airport I'm actually the closest to. So what we're going to do is we're going to make a diagram so it clearly tells us which airport we're closest to. Because otherwise, if we're somewhere in the middle here and maybe that's off by like 10 miles or something and we, crash our plane before we get there, well, maybe that 10 miles would have saved us from crashing our plane. So pretty important thing. They'd probably use radar and that kind of thing when they're doing things like this, but this is a way to find the closest locations. So again, we're going to use our compass and a straight edge. So what we're going to want to start by doing is making perpendicular bisectors between two of the points. So you just take two of your points. It doesn't matter which ones. I'm just going to start with Y and X. And I'm going to do the same thing I did before, where I've got my stab end on one of the points, pencil end on the other point, and I'm going to make my circles. Now, truthfully here, I don't usually make full circles because, like we did before, I only need to know where these cross here. So what I usually do, instead of making the full circles around, is I just make a little X where they cross, make a little X where they cross, and then shoot my line through, instead of having all those big circles. Because in a situation like this one we're going to do here, you're going to have a whole bunch of circles and it can get kind of confusing. So what I'm going to do is I'm just going to do little marks above and below is what I call it. So I've got my stab end on Y, pencil end on X. I'm going to go up here and I'm going to make a mark above, which I could, make my full circle around there, but I'm not going to. I'm just going to do a mark above there, come back around, still going through X, and then I'm going to make my mark below here. Okay, so instead of making that full circle there, I'm just going to do that, so I don't really need that extra stuff on the other side. Then, so my stab was on Y, pencil on X. Now I flip it, so my stab is on X and my pencil's on Y. And I do the same thing. So again, I don't really need a full circle because I just need where they cross. So there I get my X, still going through Y there, and then I get my X there. So see how I just made parts of circles instead of full circles, because it just kind of, it gets really sloppy if you make the full circles in. You can, but usually people get confused when they do that. So I just made my parts of circles there. And then again, what I want to do is I want to shoot my line in between here. Just like that. And basically what this does is anything that is on this side of the line is closer to X. So if our plane is like, if our only two airports are X and Y, and our plane is right here, we'd want to go to airport X. If our plane is right here, we'd want to go to airport Y because that would be closer. But we actually have 3 airports here, so we need to do more. So that splits in between the X and the Y. Now we got to include the Z in this. So I'm going to do the same thing except for with Z in a point. So I'm going to go Z and X. So stab on Z, pencil end on X. I'm going to do my marks here. So marks above and below, kind of like that. Then I flop it around, stab end on X, pencil end on Z, do my marks there. Oops, my pencil kind of broke. And there, something like that. Then I've got those 2 crossing points, so I can shoot my line through. So like that. Little arrows on these guys. So what that line does is it splits between X and Z. So basically anything that's on this side of the line, that line we just drew, is closer to X. Anything on this side of the line is closer to Z. So now we have to do the same thing with our last 2 points, Y and Z. So again, we're going to do our marks on each side, so above and below, or in this case more right and left. So I'm going to go stab end on Y, pencil end on Z. I'm going to do my marks here and here. Then I'm going to flip it around, stab end on Z, pencil end on Y, if I can get it to hold there. Do my mark, and then shoot my line through from that mark there to that mark there where the circles cross. And it does get kind of tricky because you do have a lot of random marks kind of throughout your paper. So it does get kind of tricky when you're doing this, but the more you practice it, the easier it gets. Okay, with this, whenever you have 3 points and you're doing this, they should all cross at the same location or pretty darn close. If you got a little gap in between there like I kind of do, that's not really a big deal, but they should be all really pretty close to each other. So now since they were asking us which points are closest to X, Y, and Z, what I'm going to do is I'm going to do some shading. So if I want to start with X, I want to look at the 2 lines that I used to make the X section. So I look at comparing X and the Z, which was this line, and comparing the X and the Y, which was this line. So the wedge that's in between those are my points that are closer to X. So there, my points that are closer to X are the red ones. Next thing I've got is my points that are closer to Y. So here I'm going to look in between the X and the Y, which would be this line, the Z and the Y, which would be this line. So my 2 wedges are going to be those there. And then the last one, whatever's left, is closest to Z. So that would be the blue there. So points that are closest to X are red, points that are closest to Y are purple, points that are closest to Z are in blue. So basically what this means here is, say my plane was right here. If my plane is right here, I'm going to want to go to airport Z because I'm in the blue section. If my plane is right here, I'm going to want to go to airport Y because Y is the closest. Now if you're on one of the lines, so like say we're on this line right here, this line is the same exact distance away from Z as it is from Y. So if you're on that line, you're going to almost want to like calculate wind or something like that to figure out, you know, which way to go, because it's the same exact distance away. Now, if you're at this middle point here where they all cross, that middle point there is the center of all three of those points. So that middle point is it's closest to all three of those locations. So if you're at this middle point with your airplane, really you could fly to any of those locations and be fine. And like I said, you'd probably want to take into account wind or weather or whatever, but this is just in general. So I did mention something about being closer to. So I don't remember, I think it's somewhere in the book too. But basically what how the perpendicular bisector kind of works is, I'm just going to sketch a picture off to the side here. But how it kind of works is, if I've got, and I'm just kind of eyeballing it here, if I've got a segment, say AB like that, same distance away there as there, and it makes a 90 right there. Anything that's on this side of the line is closer to A, anything that's on this side of the line is closer to B, like we just talked about. Now also, anything that's specifically on that line, so say there was a point C there, that's the same exact distance away from A as it is away from B. So any point that's on that line is the same exact distance away, whether it's above it like that, or it could be below it like this. If that was a point D, that point D is also the same distance from B as it is from A. So that line is dead in the middle, no matter if you're way up there or way down there. Okay, we've got one more construction here, and again, this one's kind of a complicated one. So there is an activity that's in the book on page 167 if you're having a hard time with this. So if you want to follow along from that, I'm going to read out of the book, but it's on 167. So this one, what we're going to do is we are going to construct a perpendicular, so a 90 degrees, to a line through a certain point. So before, when we did it, we didn't really have a point that we were aiming to go through. We were just kind of doing it in general and trying to shoot for the middle. Now what we're going to do is we're going to try to go through a separate point here. Okay, so what we want to do is, it says, given a line AB, so I drew in a line AB, so point A, point B, line going through it, and a point C that's not on that line. So I just did it a little bit above it. You could have put it a little bit more above it. Doesn't really matter. I did make it closer to B than A. I wouldn't try to put it, you know, somewhere in the middle, because then that would be more like perpendicular bisector, which isn't what we're doing here. So I kind of shifted it closer to one of my points than the other, but it doesn't really matter which one you use. So I made it a little bit closer to B because that's what the book has. And then what we're going to want to do is we are going to want to construct a circle C with radius CA. So again, we're going to need our compass here, and we're going to make a circle around point C, so the one that's not on our line, and we're going to have a radius C to A. So I'm going to connect from C to A with my compass like that, and this time I am going to make a full circle here. So I'm going to make a full circle going around, just kind of like that. So I made a circle C, so center was C, with a radius from C out to A. Okay, and then what we do is we are going to extend our bottom line out here. So since my circle doesn't cross completely on that line there, I'm going to take and extend that line out a little bit further so it does cross that. Let's see how much I can get here. So I'm just going to extend that line out so that it does cross this circle. Now yours might have crossed in the first place, that's fine, but if it didn't, extend it out a little bit. So then what we're going to do is we are going to name the intersection of the circle point A and then also point D. So that circle crossed the line at A, and it's also crossing here at point D. So it crossed at point A, and it's also crossing at point D. Now what we're going to do is we're going to make a perpendicular bisector between A and D. I don't know why I wrote A twice there, but we're going to make a perpendicular bisector in between A and D. So we're going to use the same method we did before, where we use our compass. We are going to put the stab end on one of our points, so I'm going to go stab on D, pencil end on A, Again, I don't know why I put two A's there, but whatever. And then we do our marks above and below. Hopefully you got enough room. Just kind of like that. Then we flip it around. So now my stab is on A, my pencil's on D. I do my mark above, my mark below. So again, you could make full circles there, but we don't really need them. Then what I'm going to do is I'm going to shoot a line through the two spots where they cross. Lined up good there. Should look something like that. And it should, when you line that up there, it should go through your point C, because that was our goal, was to construct a perpendicular, which would be a 90, through that point and perpendicular to our original line there. Okay, so that's kind of what we did. We got a perpendicular, so a 90, and it's through that point C, and it's 90 to AB. The key to this and why it works is because if you think about it, when we made our original circle here from C to A, this line, you're in a different color here, the line from A to C is a radius, and so when we make the circle, when we go C to D, that's also a radius, so those would basically be the same distance away, so we're basically then making a perpendicular bisector between A and D. That's how we get the C. But we had to originally make that circle C to figure out where this extra point D was going to be. Now you could have used circle B and done the same thing, and it would have worked out as well. Okay? Alright, so your book page assignment is page 168, 1 through 3, and then you're going to skip some, and then you do 6 to 10 all.